This is then the second video of memory expansion, which will be the word capacity expansion. Now the second type of expansion is called a word capacity expansion. Now what this basically means is you want to have more registers where data can be placed in. So in other words, there will be more locations or more memory registers that will be involved in this case. And if I've got more memory registers, I mean if I go from a 2K to a 4K, that also means that the number of address lines will definitely increase. The addresses will be more. So let's look at an example. If I want to increase the word capacity and I've only got 2K by 8, that's what I have, and I want to expand it to become an 8K by 8, I have expanded the memory locations from 2K to 8K. And what I want to mention here is if you do a word capacity expansion, a decoder will always be included in this type of design. Always, always, always. Just make sure you've always got a decoder. Now let's look at this slide where we do a word capacity expansion. This is just a representation of what's going to happen. Let's assume I've got a 1 meg RAM here and another 1 meg RAM here. As you can see, they've connected it together to form a 2 meg RAM. This is at 1 meg by 8, 1 meg by 8, and if you connect it in a certain way, it becomes a 2 meg by 8. So the data bits, you can see the data bits in this specific case, the 8 data bits going out and the 8 data bits going out or in, doesn't matter, it's an IO, is connected in parallel. So the data output will be connected in parallel. This specific RAM here has only got 20 bits on the address bus. So basically what it boils down to is that 2 to the power 20 is equal to 1 meg. And the same applies here. 2 to the power 20 is 1 meg, 20 bits here. On the control bus, we're sitting with this control bus here, which is basically, because it's a RAM, there's a chip select line, a read line, and a write line, and the same applies here. So what we see here, the way you connect a word capacity expansion, as you can see, the 20 bits, I mean this RAM can only have 20 address bits going to it. And in parallel with that, the bottom RAM, RAM number 2, has also got 20 bits going to it. It can't have more than that. But well, let's first of all just look at the control bus. Again, also the control bus of RAM 1 and the control bus of RAM 2 is also in parallel. So and this control bus we're talking about here will basically be the read line and the write line because it's a RAM. It will not be the chip select line. The chip select line, as you can see here, or the enable in line, this one here and this one here, is basically connected to an additional line. So if you look at this, I've said that if you do a word capacity expansion, there will always be a decoder involved. Now what we have here, this line going straight through to this enable and going, in this case, through an inverter, is basically a decoder. This is a 1 input with 2 outputs. There are my 2 outputs, but this is a 1 by 2 decoder. So that additional, as soon as you want to go to a 2 meg, you've got your address bus will increase, as I've said on the previous slide. So all of a sudden we can use, together with this decoder, we've got an extra line here which now forms 21 bits. And I will show you in the next slide how this bit here basically decides between, is the data going to come from RAM 1 or is the data going to come from RAM number 2. But this is the way to expand it. Always a decoder will be incorporated if you do word capacity expansion. Now let's look at this word capacity expansion. Let's assume I've got 2K by 8 memory devices, in this case RAM, and I want to expand it to become an 8K by 8. Well, immediately I can see 2 to 8 means that I will need to use 4 of these devices to get me to this 8 here. By 8, which means it will just be connected, the output data bus will be connected in parallel. So again, people, because this is a RAM device, I will connect all the read lines together, as you can see there. This here will be my I've got my 4 RAM devices here. My write lines will also be connected together, so I can also write into this device from the data bus if I really want to. And if I want to read, it will come from the from the memory, and it will be placed on the data bus. So first of all, if we look at a 2K memory device, all of them are 2K memory devices. So again, we've seen already that 2 to the power n is the memory size. In this case, it's 2K. So 2 to the power 11 gives me the 2K, which means 11 addresses will start at A0 and it will continue up to A10. That will be the 11 address lines. So all my 2K by 8s, all of them, will be connected from A0 to A10 in parallel. So, but this thing says, the question says, I want an 8K device. So if I want an 8K, 8K is 2 to the power 13, which means there will be 13 address lines going from A0 to A12. So I've actually got, because my memory itself can only go from A0 to A10, and I've got up to A12 here, so I've actually got 2 address lines extra. And I've highlighted this here and I said the extra 2 lines will always be connected to the decoder. This is why I've said if you do a word capacity expansion, there will always be a decoder connected. And this is why A11 will be connected to this decoder, and 12 will also be connected. 2 lines in, 4 lines out. And it will also be active low outputs. So depending on what is selected here, one of these outputs will be activated. So as you can see, only one of these outputs will be activated at one specific moment. So it will either be this RAM on the left hand side which will be active, or that one, or that one, or that one. But they can't be active exactly at the same time. It will just be one of them at one specific moment. And the address will actually determine which one will be activated. If I can give you an example, but before we go to an example, let's just look at this. As you can see, this 2K by 8, the data bus is connected between D0 to D7, and that is the case with all of them. So all of them, the data buses, is basically connected to the same data bus. The chip selects of the different devices are connected to the output of the decoder. And if I, for instance, let's say I put on my address bus all zeros here and all zeros here also, which means my address will actually be address hex 0000, maybe 0000. But the point is, if all my address lines are zeros, while A0 to A10 refers to the first position in this RAM, first one there, first one here, and the first one there. But because I've got 0 here and I've got 0 here on A11, A12, only this device, this output will be low, while this one is high, that one is high, and that one is high. So this will be the left hand side RAM will be the only one that is really active, because a 0 will occur on the chip select line of this RAM. The chip selects of the rest will be high, meaning only this data that you see in the first position will be placed on the data bus, while the rest will not be active at all. So that 8 bits, this 8 bits from this RAM will be placed on the data bus. If I, for instance, make all the address lines ones, all of them ones here, and let's say 1 and 1 here also, that means that I will basically select the bottom or the highest address in this RAM, the highest address here, highest one here, and also the highest one here. But because it's a 1 year and a 1 year, this line, the bottom line here, will be active low, activating only this RAM, which means only the bottom or the highest address inside this 2K memory device will be placed on the data bus. Because this is a 0, that is deactivated. Because this is 0, that's also not activated, and because this is a 0, that's also not activated. So as you can see, depending on your address, from a certain point to another point only, I will select from the least significant, or the lowest address rather, to the highest address from this RAM. The next addresses will go to this RAM, then this RAM, and then this RAM. So if I look at this, I'm going to make use of 2K of memory inside this RAM. I've got access to 2K here, and access to 2K here, and access to 2K here, depending on the address, which eventually, if I add it together, actually gives me the 8K by 8 memory device. This is then the end of the second video on memory expansion, which was the word capacity expansion.